Okay, so anybody on the stream, sorry if we're late. Sorry that we're late. But we're going to talk about the server now. So the server is just in Node. I chose Node mainly because it had really great GraphQL support with the Apollo server framework, which is really awesome. And it's also a lot easier to learn than the other language which I wanted to do, which is Elixir, which I still really think that Elixir would be awesome for spaceship simulators. But there's a lot of things that just come really easily with the Node that would be a little bit more difficult with Elixir. One example is the fact that I'm able to bundle everything together into one executable using Zeit's package. Thank you, Zeit. That's what the built Thorium is. It's just this bundle that runs the web server, that runs the backend and everything, and it's great. You can't do that with Elixir. You'd have to do it in Docker or some other form. And I wanted to make it really easy so people, in order to run Thorium, just have to download it, run it, and life is great. So we're in Node. That means that everything is just a JavaScript data structure. I do use classes to keep track of things. That makes it so that you can add getters and setters and methods and stuff. I probably don't do it the best way possible, but it's the way that I do it. Also, like I said earlier, it is, hey, are you looking for everybody else? Or, oh, okay. Yeah. Thank you so much for coming, and I hope that this was helpful. And if you want to keep helping out, or if you need help, hop on the Discord. And yeah, let me show you really quick. And for the sake of everybody on the live stream, I keep talking about this. I probably should make it a little bit more apparent, because it really is like that's where the community is. Right down here, you go to thoriumsim.com, scroll to the very bottom. There's this project chat. You click on that, and it's going to be like, join our server. Oh, and it just opened it up in Discord on my other screen. So, yay. So you can create an account. Discord's free, and it's really awesome. And thanks, Discord. Yes, you can run it in the browser. Yeah, and I don't know if you have an iPhone. I hear the Android version is okay, but the iPhone version is awesome. So, yeah, if it works, it works. It's mostly for gamers, but don't let that scare you if that's not your jam. Because it really, like, there are a lot. In fact, let me just show you really quick. Yeah. Yeah, that is what's called a server invite. So I have a Thorium server here that has these channels. And then there are other servers that I'm a part of in Discord. There's one here called Reactiflux, which is a React server, and that's all they talk about is just React. I never look at this channel, though. I'm just there because I want to be. Anyway, so that's Discord, and you should hop on it because that is where the Thorium community is. Yeah, voice and video chat. Tyler and I have actually done voice chat over Discord before. There's another guy that's not here today, but he and I did a screen share. He was having problems with Thorium, so we screen shared, and I was able to help him out and get him set up and running. Yes, so the link to this live stream, I don't know exactly how YouTube live stream works, so it'll probably be like a really long video, or maybe it'll be smaller videos, I don't know. But that's on the Discord too, just in the general channel. You're welcome. Thank you for coming. And spread the word. Tell all your friends about Thorium, and don't do drugs. Both of those are good things to know. Okay. We're talking about the server. So I was telling you earlier, Thorium is also event-driven. It is not event-sourced. I'm sorry. I tried, but when I was building Thorium, I just couldn't figure it out. So it's kind of this pseudo-event sourcing shindig. Although, let me try something. So it has graphical, which is a GraphQL IDE built in at port 3001, which is where the GraphQL API runs. So if you're running Thorium, you can pull this up. And I've got, you can query whatever you want, but I have it's actually a mutation. Just a development mutation that just prints, just dumps data from the main data store. So, I'm doing really good, guys. There we go. Let's see what this does. Where's my... There, check it out. So, just for everybody else's sake, event sourcing is a data storage method where instead of storing data in its final state, like with a database, like SQL, you write a value and it changes that value in the database. But you know nothing about the write itself, and you don't know about the previous states of the database unless you store that in a separate place. With event sourcing, instead of storing data in its final state, you store all of the events that happen. And then, in order to figure out what the final state is, you create a, I can't remember what it's called, a view, basically, that takes all of the events and plays through them in order and performs the actions to the database that those events would be performing. Okay? So Thorium does keep track of the events. I have the log here of all of the events that happen. You can see the event, you can see the parameters that happen. Right here is where I updated that keyboard key, and you can see all the stuff about that event. All of that does get stored, but I don't do anything with it. The way that it actually persists data between sessions of Thorium is by saving it, the entire state, the entire data store, to a JSON file every time there's a change with a debounce. So it isn't like, if you were having lots of changes happening, it isn't hammering your file system. It does it like at most, at most every 5 seconds. So that, and it batches those updates within that 5-second window. So it certainly isn't the most elegant data storage method. It's effective, it works. We've had a couple of problems in the past, but I think all of those have been taken care of with some recent changes. So that's called the snapshot, and it depends. The built version uses a different storage location than the development version. But if we come here to server/snapshots, I have a bunch of snapshot files here because people send me their snapshots so that I can debug things. But the one that is active is called snapshot-dev. As a heads up, that one is not checked into Git. I don't want your snapshot-dev. But that means that you can, you can do whatever you want with this. And it literally is just a JSON file that has all of the data itself at rest. It doesn't have any of the events. I tear those out because I don't want the snapshot file to get super huge. But there are the simulators, here's the station sets, here's the flights and missions and systems and everything. Okay? Yeah. So if I were to wipe it, it would get rid of all of the template simulators, it would get rid of all of the missions, all of the currently running flights. That's a bad plan. Some of the space centers have had issues with this, which is why there's actually the snapshot dev restore. It makes sure that if there's ever an issue saving the snapshot, that you have something that you can go back to. Sure. In that case, there is a migration system that happens in the server. So right here in source, let me go over this really quick. We've got the package JSON. I've got the icon, which currently isn't being used, but it does look pretty hot in my opinion, because I made it. Sorry guys, I'm super conceited. You have to forgive me. But yeah, there's the server icon. It's gold and white instead of purple and black, complementary colors. You have the assets, which is the images, the user-provided images and resources and stuff. A logs folder that just keeps track of all of the logs in case something happens and you aren't able to see the actual log of the console. And then the snapshots folder and the source folder, and then the test folder. So source is where all the magic happens. Let's dive into there. And like all good JavaScript apps, this one does not start with an index.js, you idiot. What am I thinking? I have a server.js, and it has a bunch of stuff that it imports that kind of bootstraps the everything, sets up some consts, and then runs through this promise chain that just goes one by one, starting up the different parts in order. So I have a migration here that performs actions that can be done without the data store being live, because the data store doesn't become live until this step right here. So then I have a post-migration here that once the data store is live, makes any changes necessary to the data store, like changing the key simulators to simulator whatever. And then I have cleanup that cleans up stuff, and that's it. So yeah, this first one does the log, because I want to make sure that logs are captured as soon as possible. Then the migrate, init. What does this do? Oh yeah, this is everything that is supposed to run the very first time that Thorium starts up. So if Thorium has never been started before, this takes care of all of that stuff. That's creating the first snapshot with the default snapshot and downloading the default assets, which I host myself. Let's see, broadcast. This sets up a Bonjour process. Bonjour is an auto-discovery process that lets all the computers know that Thorium exists. This doesn't have anything to do with web browsers, but this is one of the cool features of the client, is if you open it up, it'll detect any Thorium servers that are running, and after a timeout, it'll automatically connect to the first one if there's only one server. So that's really nice if you don't want to have everybody type in the IP address, it just automatically connects. Then we start up the client server, which hosts the HTML files and all of the static assets. Start up the Express server, which is the GraphQL API, the assets server, and the WebSockets. And those run, so if we're in production, the built version, it uses port 1337 because Thorium is super elite. I'm sorry, I'm such a nerd. You have to, I don't have to apologize. And then port 3000 on development. And then the GraphQL port is just one more than that, and the WebSocket port is just two more than that. So, yeah, so let's start up, and then we start up our app, which grabs the snapshot file, loads it into memory, and we're ready to go. And then it does post-migration cleanup, so pretty straightforward. I'm not going to go into all of the details of all of those, but if you want to dig into those files, I'm pretty sure they're mostly self-explanatory. There are a couple of comments. I really, though, this project has mostly been about, like, for me, myself, so I don't have a whole lot of comments, and I really apologize. If you ever have any questions about something, please let me know so that I can answer it. Yeah, I'm a sucky programmer, I'm sorry. Just to be clear, I think everybody's a sucky programmer at some level, so I'm not being self-deprecating too much. So right here's where the magic happens. I know I keep saying that, but this is the app.js file. This is the data store where I create this events class, and then down here at the very bottom I instantiate it. Nope, I don't instantiate it. I instantiate it here. There it is. And then handlers, yay. And it just has the structure of properties on it. Most of them are just arrays of stuff in the constructor. When we first start this, when Thorium first starts, it runs the init function that's going to pull in all of the data from Thorium, like from the snapshot, bring it in, load it up for the first time. And this right here just goes through and instantiates all of the classes for all of the objects in this. So I'll show you what those classes look like in a bit. Since JSON doesn't have classes, it just is objects. I have to do this instantiation shindig. Snapshot just automatically snapshots, and then anytime an event happens, I have this handle event function where we take in all of the information about the event, save it to the event store right here, and then emit the event, because you'll notice that this is an event emitter class. So, and that's how the events all are handled. I'm not being very good at explaining this. Does anyone have any questions? Is this going over anybody's head? Event sourcing? No, we haven't touched GraphQL yet. Yep. This is just JavaScript data. I'll talk about GraphQL in just a bit, though. This is actually, so when I was trying to figure out how to do event sourcing, and this was my feeble attempt at doing event sourcing, and it didn't, it kind of works, it kind of doesn't, it's whatever. It's all in memory, yeah, which is really nice because it means I don't have to have an external database, no messing around with Mongo or SQL or anything. Yeah, setup's really easy, it's dang fast. Nothing faster than that, as far as I know. I've never had that issue. Nobody's ever run out of memory, as far as I know. And whenever the snapshot is saved, it trims the snapshot. It removes the events. Yes, when it saves the snapshot. So that means you'll continue growing in memory until Thorium is shut down, and then when you load again, it'll load the snapshot, the events will be clean. So, certainly not ideal. And again, I do nothing with the events as of right now. One thought that could happen with the events is to perform analytics on them. That's one reason why I still have them being stored, so that at the end of a flight you could just dump all of the events for that flight and perform analytics on how different people did different things. But there hasn't been any effort in that area, and I don't know enough about analytics, and like I haven't done that ever, so I don't know what I would even be looking for. I'll leave that to other people that feel like doing that. Okay, let's talk about GraphQL. The way that GraphQL works. Any other questions before I keep going? Okay, the way that GraphQL works, for anybody that doesn't know, is you have a schema, which in our case is actually just a big chunk of text. Let me show you. The schema string is being concatenated from everything inside the schema folder, which is just a bunch of JavaScript files that are actually just exporting string. That's all that they do. There are better ways of doing this. I haven't done it yet. Apologies. We can improve it in the future, certainly. No, this is schema sting, like the singer. And I use NodeMon for the server, so it automatically restarts, which is awesome. Although one caveat, automatic saving of snapshots does not happen in development, because that could get annoying if you're trying to test a specific feature and you change something, and then you're like, I need to go back to what it was before. So this way, all you have to do is just restart your server. It goes back. There is an easy way to do a snapshot, though. You just come over here, click the snapshot button, and that saves a snapshot of your current state. So just as a heads up. No, it's not trigger restart. Okay, and so you see here, we've got this just big chunk of text, has commas here randomly because I'm probably a bad programmer, I guess. It looks like all of these are mutations. And the way that mutations are in Thorium, like I said, you can return data with mutations, but in Thorium only a very small minority do that. Certainly we could have more that do that, but just the way that I've designed it, I don't know a good way of doing that since it's event-driven and, yeah, complicated. Yeah. But here you can see it has the name of the mutation, the arguments of the mutation, and then what the mutation returns. Probably better, so dang many mutations, man. Right here, these are our queries. So I can query the officer's logs with client ID and flight ID, the bang after the type. So notice I have the name of the argument here, and then I have a type. And a bang after the type means that it's required. The GraphQL query will not go through unless you have that bang. And then at the end, it returns an array, or a list, depending on your nomenclature, of logs, which is a type that I've defined up here. So here are all of my types. Cool. So if we go into the schema folder, you'll see that I have a types folder. And here I've got all of my types for long-range comm. And every single item on here has a type. And that type could be another type, or it could be what's called a scalar, which is the basic cardinal types, I suppose you'd call them. Strings, ints, floats, booleans, IDs, which are either numbers or strings. And And you just compose these together, these objects, to create these types. And then you have, let me go back here. Sorry, I'm jumping ahead. Then you have your queries, which are just what you're querying, the arguments for the query, and then what you're returning. So this is going to return an array of core feed items for a specific simulator. Awesome. You have your subscriptions. So here's my core feed subscription, which is very similar. It's called core feed update. And it takes a simulator ID and it returns a core feed list. And I'll show you how to do this. It's just a pub subsystem. So if anytime there's a publish for the core feed update channel, it will send the subscription to anybody that's subscribed to it. And then mutations, all of them return strings because, again, you don't return anything. Let me come back here to the core feed. Yeah, and so when you ignore a core feed item, you give it the ID of the item, and it just performs the action. For every item in the schema, not every item, but for any item that you want to actually do something, you have a resolver, okay? The resolver takes the query or the mutation or the subscription or whatever that you have and translates it into the actual action that's performed. So if we go to our core feed resolvers, one thing that I could do is split out the resolvers into queries, mutations, subscriptions, and types. Haven't done that yet. It might make it a little bit cleaner, but then again it would split stuff up into multiple files, so I don't know how I feel about it. We can check.
I can show you after.
No, that's an interesting idea. It would be a significant refactor,
Yeah.
but I mean, it wouldn't be changing code, just where things are. So it probably. No, I'm following. I think that's a good idea. It's an interesting one. I'm out of water. Yeah, I mean, we definitely want to build on stuff. I'm on 1.4.0, so I'm not on 2, which is the latest. And I don't even think 2 is out officially yet. Oh, good. Okay, maybe I'll upgrade someday, soon. But that's the way that resolvers are right now, so we'll deal with it. In this case, app, remember, is our main data store. That's where all of the data lives. And I have my pub sub and with filter, which help me with subscriptions. And I have my core feed resolver. Takes this root value for queries. Root value doesn't mean anything. I've never used it. But it does give you some information about the query that could be helpful. And then the arguments. In this case, I have simulator ID as my only argument. And I'm just doing this thing where I'm checking if there is a simulator ID argument, then I'm going to filter this value, all of the core feeds that are in the app by the simulator, and then return that. Ta-da! Pretty simple. Some of the queries are a little bit more complicated, but this is the basic idea. You take data from the app, you filter it based on the arguments to the query, and then you return the data. And you make sure that the type for that query matches the data that you're returning. Typically what I'll do is I'll take the class that I'm returning and use that class to create the schema. Or vice versa, since the schema has types, that makes it a little easier for me to make the type when I'm making the type. Let me show you the class for core feed just so that we can see what this looks like. Just a regular JavaScript class, ES6 class, so I suppose it depends on your definition of regular JavaScript. As a matter of semantics, every single class should have a class property that is a string form of the name of the class. This makes it so that when the snapshot is being instantiated for the first time, it knows what class to use to build this object. I'm sure there's a better way of doing it, but I haven't figured it out. So if anybody knows a better way. Can I try that really quick? Let's try that. I believe you, but or Oh, but the problem is that isn't getting saved to a JSON file, to the JSON snapshot. So you do have to have it somewhere as a key on it.
Yeah.
But just for kicks, yep. So then if I do, and then, okay. Oh, okay. So if I do, oh, I suppose I need to do new here. Oh, yeah, you're right. There we go. And then it does not get serialized. So I could change the serializer function so that you don't have to include that, which would be awesome. But then again, there are times, especially when it comes to systems, so we're going to get into the actual data structures of how Thorium works and the different parts of it. But with systems, I'm referencing that class field to identify what type of system it is. Yeah, so it's like internal communications versus sensors versus torpedoes, you know, and that's the way that it identifies them. Since since system is a generic type, and there actually is a system interface. Hi, Nathan. Good, how are you? So we're right now doing a deep dive into the backend of Thorium. So this might be interesting to you. It might not. Crystal's outside doing a HTML and CSS kickstart. So if that's more interesting to you, you can go out there. All of the stuff that I'm doing is being recorded. You're welcome.
Awesome. I want to be part of this.
Okay, great. You're welcome to be here. So we're just talking about how all of this stuff works together. So this is probably the way it's going to stay, and it's not super clunky, and it will warn you if you have, well, it doesn't warn you immediately. I should probably add a check for that. We can write an automated test. Make sure that every single one of the classes in the classes folder has a class property. That would be awesome. We can do that. Anyway, but it'll warn you if you try and load a snapshot and it doesn't have a class property, it'll freak out. We have the simulator ID, which is going to be a property of many of these classes because a lot of these things relate to a simulator. Simulators are kind of really huge. There's a lot of stuff that goes on with them. And then all the stuff that's necessary for the core feed item itself. So the text of it, the title of it, the timestamp, the station that it's associated with, whether or not it's been ignored. And then notice that the core feed is really cool because it lets me pull it up really quick. Core feed, there we go. It lets me click on it and it pulls up the core component that I can then use to manipulate this, to perform the action. So that component is not necessary. If it's not there, then I can't click on it, but it's included if, yeah, anyway. Notice that the way that I do this is, for most things, I have it construct with params dot, whatever the property name is, or the default constructor. And I do that because when I instantiate the flight at the very beginning, I take the snapshot and I load all of these classes, and I want to make sure that it's loading the data in here from the class first and then from the default for whatever the property is. Does that make sense? Any questions? Okay, cool. So that's just kind of the way that classes should be made. Make sure that they have they pull it from the constructor parameters, and if there's not one of those, then provide a default constructor. Something sensible. So like in the event, like you're never going to have a core feed item without a simulator. That just doesn't make sense. I'm not going to put something just random here. I'll just use null. It makes sense. I could use anything here that I really wanted to, but null works. And then I have my properties, or not my properties, my methods on here. This just makes it a little easier to perform certain actions on the object. So let's go to my resolver again for the core feed. And I have my one, we're not going to worry about the sync timer because I literally just threw that on the core feed because I needed a place to put it and I didn't want to make a new resolver. That's why it's there. We'll just look at this ignore core feed action. So whenever someone performs this mutation, this is actually the way that most mutations work. It's a lot of boilerplate. I wish there was a better way of doing it. I don't know if there is. If somebody can figure out a better way of doing this, that's great. Because if you look at something like the sensors, the mutation for sensors looks like all that. Yep. Over and over again. Woot. App.handle event, the args, the name of the event, which is the name of the mutation in most cases, and context. And context is something which is passed with the GraphQL query for every query, and I want to make sure I catch that. That includes the simulator ID, the station name, the client name, that sort of thing. Just some metadata that we can use for analytics in the future or whatever. Okay. So, like I said, lots of boilerplate. That could change. I don't know how. I haven't looked into it. It works. And I have a convenient helper tool that makes it so you don't have to think about that much. So let's see what happens when we handle an event. Go back to app. I already looked at this briefly, but it's going to add a timestamp. It's going to create the event object itself. It's going to pull some stuff out of the context. And then it does this magical this.emit. Woohoo! If you know what JavaScript event emitters does, that basically triggers the event to happen on anything that is listening to that event. The event listeners all live inside of the events folder. Hey! So for the core feed, I just have this one event, app.on, ignore core feed, it's the name, and then the arguments here. I just have the ID, and then I perform my logic. So I have my shindig where I'm finding. Yeah, interesting. The way that I programmed this, it looks like ID could either be the ID of a specific core feed item, and then it ignores that single item, or it could be a simulator ID, and if it finds a simulator with that ID, then it ignores all of the core feed items for that, which is where this ignore all button, how that works. So I perform the action. In this case, I'm just finding all of the core feed items and I'm looping through them and ignoring them, or I find a single item and I ignore it. And then at the very end, I do my pub/sub/publish core feed update, and then whatever it is that I'm passing into that. This is another place where I'm a very bad programmer, and there are definitely improvements that could be made on this front. This right here is fine. This is the name of the subscription that's going to be triggered and sent out to all of the peeps that are subscribing to the subscription. This right here is the data that's being sent to the subscription. In this case, I'm sending literally every single core feed item, which is not ideal. What would be great is if I just sent the core feed items that pertain to this atomic action that was performed, so that instead of sending subscription updates to everybody, regardless of if it matters to them or not, I only send it to the specific clients that care about this action. Okay? There are certainly ways that we could do it. We could make it so that we have it as an object, and we have the simulator ID here, and then the items that are actually going to be sent, and it filters based on the simulator ID. I don't know. That's something that could be improved. There isn't an issue for that, so I wouldn't worry about that if I were you. I can fix that when it becomes an issue. So now that that subscription's been sent, we come here to our subscriptions. Yay! And here's that core feed update. This one's a little bit different. In this case, in the case of the query and the mutation, all that it is just a function. I don't know if you noticed that. I just kind of assumed that you did. These are functions that return. Subscriptions are a little bit different, though. It's actually an object that takes a function for resolve, and what resolve does is it takes the data, munches it, and then sends it out. And then I have a subscribe function that handles how the subscriptions, whether or not a subscription should be sent to somebody. This is an Apollo thing. It's just standard practice. With filter is something that I include to make it so that even though I'm a bad programmer, not everybody gets the subscriptions that they're not supposed to have. So in this case, it's only going to send subscriptions to clients that have core feed items that actually matter. Yeah, this is kind of messy. I'm not proud of this. We should move on from here. Any questions? If this is something that you want to dive into, there's a lot of examples of how I do it here. There's also a lot of opportunity for trial and error, and of course the Apollo documentation is awesome. They're super legit peeps, so you can look at that for how to do all of this stuff properly. Okay, gosh, that's pretty much everything at a high level. There are a couple of smaller things that I could talk about. We've got the processes, which are the regular processes that run in the background. Things that like increment the heat, or move sensor contacts, or anything else that is happening in the background. So let's look at the reactor, because I think that one's kind of interesting. I'll start here at the bottom, because I have these two functions that are called just in this reactor thing. And let me go back. Whenever you're making a resolver, make sure that you export it and then import it into the right folder. So here, or into the right file. I've got a queries file here that has all of the queries. I've got a mutations file up here that has all the mutations. Types file, so you can actually have resolvers for specific types. That can come in handy, but I'll let you look up that yourself. And then a subscriptions here. So there you go. Make sure you import that into that. Same thing with this, except instead of exporting these, you just import them. When they get imported into this file, it executes the file itself, which just gets these processes running. I could probably have a better task manager system so that if a process has an exception or something breaks, that it can start up again, but I'm not worried about that right now. It's not a huge deal. Typically when that happens, Thorium server goes down altogether, so I'm a bad programmer, and that's okay. So it's going to run these two, and you'll notice that these have set timeouts running, so just this loop running in the background for all of these different processes. And in this case, well, let's just look at the reactor heat. This one actually cools it down. Now, I don't want to look at this one. We're going to look at this one, because this one's a little bit more pertinent. You notice that with flights, you can pause and resume flights. And that actually stops these processes for that flight. The way that does that is by looping through all of the flights, seeing if it's running, and then going through each of the simulators, and then just doing these loops within loops within loops until we get eventually to the simulator itself, and then we grab all of the reactors for that simulator. So, in case you don't know, the reactor is something that provides power for the ship. The reactor is also a dual-purpose system. Reactors have two different models. You can either have a reactor that generates power or a battery which stores power. They're part of the same system. Just because they operate very similarly, they could be split out, but I decided to do it this way because sometimes I make silly choices. Seemed like a good idea at the time. Anyway, but what we need to do with this loop is increase the heat of the reactor, because as the reactor produces power, it's going to increase in heat. And we also need to decrease the level of all of the batteries on the ship. So we get all the systems on the ship, we see how much power they're using, and we get all the reactors and the batteries on the ship, and we figure out how much power the reactors are putting out and how different that is from the power that is being used. If the power being used is more than the power the reactors are putting out, then we decrease the battery level for each of the batteries. So right here, go to each of the batteries, decrease the level so that the batteries are being discharged because we're using too much power. Or charge the batteries if we're using not as much power. It goes into the batteries. And then we have this thing here for adjusting the reactor's heat, which is something that I've fiddled with so much because people are like, oh, the reactor's too fast, oh, it's too slow. Okay, fine, we'll figure it out. So right here, I just use a little algorithm that increases the heat in two levels. There's just the standard heat increase based on the efficiency. So if the reactor is running at a low efficiency, the heat doesn't go up as much. But if it's running at a high efficiency, which I know is weird, it's actually more close to output. So if the reactor output is 100%, then standard heat. If it's 50%, then half of that. If it's at 150%, then that. Okay. And then if the power is imbalanced, it's going to increase the reactor heat more because that puts some strain on the reactor. So make sure your power is balanced. It's a hat nod to Victor. And then I do some stuff with dilithium stress because I decided to build that dilithium stress into the reactor too. And if you aren't using dilithium stress card, then you don't even notice. Notice though, at the very end, I have somewhere. Where is it? In my reactor heat, I have pub sub publish. That's it. And then up here, the trigger warning. So I guess what's happening is right here, I'm actually handling an event for the reactor battery charge level. And inside of that event, it triggers pub sub publish for updating the reactor so that these changes get pushed out to all of the clients. So just make sure that that happens somewhere in these processes. But make sure also that it doesn't happen too often. Since we're running in a web browser, we only have access to TCP, which means our network messages are always going to be sequential, which means, yeah, if you're sending if you're maybe sending a couple a second, you'll be fine. But if you're just hammering it, it's totally going to wreck the client and the server for that matter, probably. Maybe even the router, yeah. So be judicious with your use of these processes. Test to make sure that it runs well and that you're not sending too many messages and that you're only sending messages when you're supposed to be, like when there's an actual change that's happened. Sensor contacts is a good example of this. I have a send update up here that I just toggle if I need to send an update based on certain circumstances. And you'd be surprised, sensors actually sends very few updates for moving the sensor contacts. So this shindig here, that actually just sent one update saying this contact moved from here to here. And then I have a deterministic function that knows the start time and the end time of the contact moving, and then just moves it based on the current time. So that's going to make it so that the sensor contacts are always going to be in sync across computers and cores, and station, of course. So that means I don't have to send a lot of updates. So be smart that way. I wish that I had a better network stack in place for doing this kind of intelligent thing, but I didn't expect Thorium to become a game engine, so deal with it. We can rewrite it someday to make it an actual game engine. That would be sick. That would be so cool. Okay. I've got imports here, which is kind of janky. This is the one part of Thorium that does not go through GraphQL. It goes through just regular API calls to the Express. But it allows you to export and import missions, simulators, library entries, the assets. It's just a little bit simpler to handle file uploads via regular HTTP calls than through GraphQL. So that's the way that goes. Have some helper functions for different things. And that's about it. Crew. Crew is just some JSON files for first names and last names. So if you want to add your name to this, it's probably already there. Like Keith and Nathan and Tyler and John, Jahan and Chris and Chuck. Oh, there isn't a Chuck. Chuck, what am I doing? You're a donor. You're not in there. Princess. So, yeah. No, you know, my favorite is frickin' Kashai. Kashai is such a... And Talarin, yeah. Yeah, also, if you guys need baby names, you're welcome. Hang on. My favorite baby name... Huh? No. No, Crystal and I have no announcements to make as of right now. Although, okay, so I probably shouldn't stream this, but I'm going to deal with it. Crystal and I actually do keep track of our baby names that we have, so these are the names that we might name our children. Don't steal them. That is actually Megumi. So that's just the Japanese character next to the transliteration. Probably a middle name. It is Japanese. Yeah, it means grace. Yep. But yeah, Reverie Rain Anderson. I mean, come on, guys. That is like hardcore superhero name right there. Except the Anderson. Anderson's boring, but whatever.
It's just their alternate.
Yeah, exactly. So if you want to add names there, that's fine. And then the positions here, just random ship positions, and then the ranks. And you'll notice that it does duplicate. That just gives a general magnitude of how many positions, how many ranks a ship should have on it. So there are going to be a lot of cadets, a lot of lieutenant junior grades, not many commanders, and like no captains. Yeah, 118 commanders on a ship, that actually does seem like a lot. I don't know. Anyway, so that's that. Chuck, I'll make sure you get at it, don't you worry. Any questions? That's the back end. Like, I don't know really what more to tell you. We could dive in and actually create some stuff for it. But I also want to make sure that we get to the other stuff on the schedule. So you guys tell me what you want. I think we might, as soon as you tell me what you want, we're going to take a quick couple minute break so that I can chat with Crystal, and then we'll dive into more stuff. Okay? What do you guys want to do? Do you want to work on something? Do you think you have enough to work on something? Do you want to watch me work on something? Cool.
Like something that might be helpful is like going around and seeing which person really wants to work on and then helping you get started on that.
Okay, that's a good idea. How about this? Go to GitHub page, github.com/thoriumsim/thorium, or just Google Thorium Sim. We're top on Thorium, or on Google, which is awesome if you type in Thorium Sim. So there you go, SEO. Yay. And Matt, you punk. And then if you just go to the Help Wanted tag label, these are all the things that I think would be great for first-timers to work on. They certainly are not small or mini. There definitely is a lot that could be involved in some of these things. But they don't require a substantial amount of context outside of what I've already just told you. Okay? So look through that, particularly the items for the workshop. Those are some that I think might be fun to dive into. And if there's something you want to work on, figure that out, let me know. I'll be back in 3 or 4 minutes. And yeah, I'm going to